So within chapter 2, we're looking up at the skies and basically kind of going to describe some things that people throughout history have noticed about the skies. One of the things is that if you were to have a camera where you could like open the shutter and leave it open, you could create what we call star trails. So the thing is you can kind of see these. These are probably in the southern hemisphere, so they're probably going clockwise, okay? But actually, these stars tend to kind of move about a bullseye, okay? And in the southern hemisphere, there is no pole star there, but in the northern hemisphere, actually, that is Polaris. Okay, and so I almost made it, could have made it one of your labs, and one of these days I might. But if you just find, for instance, the Big Dipper drags around Polaris, the North Star, throughout the course of the night. So that's what this is. And actually, the movement of the stars like this, kind of in a bullseye centered around Polaris, going counterclockwise, that movement is created as just because the Earth is spinning on its axis of rotation. So what else do we see in the nighttime sky? What have other people seen in the nighttime sky like forever, right? Well, one is that the sun appears to rise in the east and it appears to set in the west. So this movement of the sun and of the moon, sometimes the moon is in front of the sun, sometimes the moon is behind the sun, but this movement is also again related to the Earth spinning on its axis of rotation. Those movements, whether it's stars moving throughout the course of the night or the sun or the moon, that's actually called diurnal motion. Okay. Now, stars we're going to talk about just briefly in lecture, but more hopefully in labs if you get out there and kind of dabble in trying to understand or trying to find constellations, sets of stars in the nighttime sky. But stars appear to be fixed relative to each other, and that's how we can make stars. We can have, that's how we can make pictures, like a picture of Orion, the picture of the Big Dipper. Okay. They appear to be fixed, while the sun and the moon and actually the planets move against the background stars. Okay, so stars look like they're kind of at the same location, but they actually are at different distances from the Earth. Now, as the Earth as the Earth orbits the sun, it changes its location in space, and you would think that stars at different distances, we would see something called parallax, where as the Earth relocates, we would kind of see different pictures made because the stars are at different locations, and they would all kind of make a different angle from our perspective with each other. But actually, because they are so far away, and we'll be talking about this thing called parallax, if objects like the stars are so far away, they don't exhibit parallax as the observer, in this case the entire Earth, relocates. One last thing to kind of point out on this slide is we see something called the Milky Way. Okay, the Milky Way actually will extend from horizon to horizon. The view of the Milky Way, by the way, the Milky Way looks like this kind of wispy sort of cloud sort of cover. It doesn't look this intense, but the Milky Way will look different throughout the year as the Earth changes its position in orbiting the sun. So we'll talk more about what the Milky Way is momentarily. Constellations. So the little bit about constellations, this is like a very busy part of the slide. It's all kind of stuck here, but a few things is that actually we have a current set of pictures that we see, and we call them pictures that the stars make in the nighttime sky, and we call them our constellations. Various cultures throughout time have had different pictures. That makes sense, doesn't it? Actually, ours right now are oftentimes have associated with Greek and Roman mythology. There are 88 constellations, And some constellations, and we'll talk about this, I bet you already figured, some constellations actually only the southern hemisphere can see, and some constellations only the northern hemisphere, or tends to be the northern hemisphere, can see. As we orbit the sun, throughout the course of the year, it takes us 1 year to go around the sun once. We actually, our nighttime skies, when we see the constellations, will be different sets of constellations. So those actually will change throughout the year. What constellations you see also change by what we call latitude, okay? And latitude, our location, I'll talk about that in a slide coming up, okay? Our location on the Earth. That also means that you'll see a different set of constellations. So just a little bit to kind of bring in a constellation here. Okay, again, your best bet if you want to be able to look at the nighttime sky and to point at constellations to show somebody else is to have practice at it. And I mentioned the Whitty Observatory Complex. Come on out and we'll kind of give you a primer on that. So the constellations here, there are, let's see, Canis Minor, a constellation, Monoceros, a constellation, Canis Major, Lepus, and Orion. Now, to be honest, I don't usually pick out Monoceros, nor do I pick out Lepus, but I love the constellation Orion. And actually, it's not too hard to pick out Canis Major because Sirius is Sirius is the brightest star in the nighttime sky. It doesn't mean it's necessarily the closest or putting out the most amount of energy, but it is the brightest from our perspective. And Canis Minor, not too hard to find. So those are constellations in yellow there. Another little bit about this figure. Notice that we have the winter triangle marked out. The winter triangle is actually 3 stars from 3 different constellations. So we have Betelgeuse from Orion. We have Procyon from Canis Minor, and then we have the dog star. Actually, this is called the dog star. The dog star Sirius from Canis Major, and together they make up what's called the winter triangle. And no, the winter triangle is not up right now, as I am recording this in the fall 2015. So just another couple figures with some constellations. An important constellation because it is one that I know at the observatory people are like, oh, I found the Big Dipper. And actually, sometimes I don't have the heart to tell them, the Big Dipper in and of itself is not a constellation. The Big Dipper actually is what we call an asterism. Asterism. And an asterism is a subset of a group of stars. Actually, the Big Dipper is part of the constellation Ursa Major. So if you can find the Big Dipper, it probably makes you smile too. If you can find the Big Dipper, then you're on your way to finding the North Star, or Polaris, right now. So what you do is you focus on the bowl part. That's the bowl part. This is the handle part. You focus on the far 2 bowl stars in the Big Dipper, and you go up, okay? And they will direct you to not a really bright star, but a moderately bright star, which is the star called Polaris, and right now actually it is our North Star because the Earth's North Pole axis of rotation is always directed towards Polaris. So use the bowl stars in the Big Dipper to find Polaris. And then once you found Polaris, actually that is in the handle of the Little Dipper, okay, which is another asterism in Ursa Minor. So again, once you found the Big Dipper, you can also find a star called Arcturus. So this time you focus on the handle of the Big Dipper, and it arcs, or it moves on over to the star called Arcturus. And Arcturus is in a constellation called Bootes. If the horizon is such, then sometimes you can go ahead and after you arc to Arcturus, you can get it speed to the star called Spica, which is a star in Virgo. You can also use, again, depending now upon what time of year it is, You can also use, let me pull up a different color, the bull stars, the bull stars that are closest to the handle, to drop down and find the star Regulus, which is in the constellation Leo. I love Leo too. Regulus, excuse me, not Regulus, but the constellation Leo kind of has two parts. It has the sickle part that kind of looks like a backward question mark, and then it has a triangle part, which kind of, it's his butt part. So those two parts, if you see them in the nighttime sky, are kind of distinctive. Looking at the other figure, got over here, that kind of dot, 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 dot in the background, actually that is the Milky Way. Okay, so that is actually the plane of our galaxy. And it's almost poetic, but the Milky Way, flying up the Milky Way, is Cygnus the Swan. Okay, a group of stars called Cygnus the Swan. And Cygnus is sometimes called the Northern Cross. I bet you can kind of see that. Cygnus has a bright star, Deneb, which is in the summer triangle, which is up right now. So we have Deneb in Cygnus. We have the star Vega in the constellation Lyra. Then we have the star Altair in the constellation Aquila that make up the summer triangle. Let's see, what else do we have? Oh, I guess on this slide are two of my just like favorite little constellations. There's Delphinus, the dolphin, I can almost see that, and Sagitta, the arrow.